So I'm not always someone who likes to do a terminology video to begin with. I like to just mention it as you go along, but this is one situation where there may be some words pop up that just knowing ahead of time what we're talking about might be helpful. And also it's kind of like a preview so that you can get the what on earth are they talking about out of your head. So we have these two terms right here. These were actually both in your polyatomic ion lists, the hydronium and the hydroxide in Gen Chem 1. So hydronium is H3O plus. It has to have that plus sign. And I'll tell you too, often, especially if we're like kind of getting fast when we're writing, people will use H plus interchangeably with H3O plus. And technically this is the correct term, the better term, but people will use either one of them. And so like if you're looking at a favorite YouTuber, you're trying to figure out how to do something, and if they use H plus, like don't let it throw you. It could be hydronium. It probably is. Hydroxide is OH minus, and it has to have that negative charge on it. As a little note, hydronium, having hydronium, this eventually will be able to be converted into pH, and this eventually would be able to be converted into POH. There's some equations you'll learn that will let that happen. So just giving you heads up there. So conjugates. So conjugates are basically, you know, like a conjugal or whatever match. Like they are pairs that are really that are related to each other in a reaction. So for example, if I have this right here and I have it reacting, I'm going to write water as HOH. Then this is what this one forms. And the ones that are mostly similar, so like we're going to look for this guy on the other side, something that has most of that. And so that's the one. And so the ones that are similar and related to each other, they are conjugates. And then the other pair is a conjugate also. So for acid base or acid with water type of reactions, those all have conjugate matches, and you need to know which ones they are. And eventually you'll learn to tell which one's the acid in the pair, which one's in the base in the conjugate pair. So, and also you can even make inferences with strength and stuff. So that's conjugates. Amphoteric. So amphoteric is something that can act as an acid or a base. And these are kind of unique because these ones are going to have a charge and they'll have at least one H or at least one OH. It should be at least one H. So an example of something like this, that has a negative charge and it has an H. This can both accept H's and it can give that H away. Another example would be, so HS minus, would be HSO4 minus. Another example would be H2PO4 minus or even HPO4 2 minus. All of those have charges and they all have at least one H. Here's another one though that doesn't have a charge, and it's actually very interesting, and it's water. So water is also amphoteric. You'll learn some more of these, but water is kind of the special case here. But you need to know that one's amphoteric. And going up, I got a few more. Some of these are very, very fast though. So monoprotic, things that are monoprotic are like mono. Mono means one, you know, one proton. So HCl has one proton, HClO4 has one proton, HBr has one proton. Hopefully you're getting the trend right there with the one protons. This would be two protons, so like H2SO4 is a pretty popular one. This one has three protons, so H3PO4. So monoditrite. Polyprotic is just generically saying that it has more than one proton. So the H2SO4, H3PO4, those ones can be polyprotic. All right, so binary, I know that says 2. It means that it has an H and some other type of element. You can have more than one H and more than one of that same type of element. But it just means that it's got two different types of elements in it, one of them being an H, for, well, to be a binary acid. So again, like HCl, that's binary. But HClO4 is not, because it has an H, a Cl, and a O. So that is not binary. HI is binary. H3N, if it existed, that would be binary. Again, because it has two types of elements. And we can jump over to the H2S even also. Again, two types of elements, binary, an H and an element. And then we have oxoacids, and these have an H, an O, and an element. So that one I crossed out up there, that's one. H2SO4. So you've seen how we're having H's and O's, and then we have an element in the middle, H's and O's and element in the middle. So those are oxoacids, and those will especially be talked about when we're talking about the strengths of acids.